So signals is something we have already since Angular version 16. At the time of this recording, we are at 17.3, and we see that the signals are becoming more and more integrated into the Angular framework. With the latest version, we see a new API, which is responsible for all the things in terms of component communication, and it replaces the old decorators like input, output, the viewChild, the content child, with functions that in most cases return you a signal. So the advantages that you get with signals are, first of all, some applications will gain significant improvement in terms of performance. Not all of them, especially those who don't have any performance issues. Especially those very simple ones, they will definitely benefit from the lightweight reactivity compared to RxJS, because signals are also like a reactive data structure. Then what we also get is that the expression has changed error, so some kind of error messages will also go away, and as we will see later, especially the developer experience is really improved. And we are also quite safe for the future, for the upcoming features. For example, if zoneless goes away, if we get the signal components, we will not have to touch our code that often. Most of the features of the signals are still in developer preview. There are now different opinions on should you wait, should you not wait. I have a clear opinion. I say yes, please start using signals right now. I will say something about the detailed reasons at the very end in the summary. But this video should really give you a guide. It should I want to really explain you to all the main features, all the functionalities, everything you have to know in order to use signals, but also this new APIs which are based on signals already. This video is very long, so you don't have to watch it in one go. On YouTube, the chapters are marked, but we have 4 main parts. First one is the basic about the signals. Then we cover some advanced stuff like the glitch-free factor and so on and so forth. Then interoperability for RxJS, and at the end, this new API where we don't use the old decorators anymore. A little bit of an introduction. So my name is Rainer Hannekamp. I am a Google developer expert. I'm also part of Angular Architects. So if you're looking for a training, workshops, consulting in terms or in the area of Angular, then I hope we might be a good candidate. But now let's start. Now, before we start, some words about the change detection in Angular. Whenever we change a property in a component, then this change is triggered via an event listener, so a DOM event, or via an asynchronous task like response from an HTTP request. What Angular is doing then is that there is a library, the Zone.js, which is aware of these kind of events and then triggers the change detection. Angular starts from the top of the component tree, which is the app component. It goes through the complete component tree, and it also always checks the TypeScript class of the component, the properties, the values of the properties of the TypeScript class with those that are currently rendered in the DOM. And if it sees that there is a certain change, then it updates only that particular DOM element. Now, this kind of approach is a little bit costly, not in terms of access to the DOM. This is very efficient. You can't do it any better, because when there is just a change in the text node, then only the text node is updated and nothing else. So how can you improve that? The problem is more that the change detection has to run quite often, even if there was no change. If we click on a button and it starts an asynchronous task, then we didn't change anything, but still the change detection needs to go through. And of course, always this kind of the requirement to search for a change. It would be way better if the change detection, when it starts, knows that there is now a change, and not that it just knows about the change, but also where the change has happened. And this is what signals will improve. Because with signals, the future, the signal component, the last version of it, where we are only working with signals in our component, it would be like this. So the signals themselves, they are reactive data type. So there is a reactive graph, an internal reactive graph, where the signals know if they are depending on somebody, on another signal, or what kind of consumers they have, so that they also have to update to notify them. And these signals are then used in our template. And then Angular, the framework itself, is also or acts also as a consumer of those signals. So the signals will update the framework in that sense, will tell it, hey, look, I've just been updated. You might want to do something about it. And with every reactive model that we have, there is also an option for side effects. And in a way, very simplified put, we could say the only thing that Angular has to do when a signal changes in the template, that it just says, okay, I'm running the change detection on that particular part where that signal is used. So the rendering, the DOM update is just a side effect of those signals, which also means the perspective will change from a component tree to that signal graph, because this is where the data comes from, and this is also where the change detection, where the update of the DOM needs to be triggered. So that's it for the theory, and now let's take a look at the real application. All right, so this will be our application for the rest of this video. As you can see here, it is a list of different holidays. It's my usual application that I use. We have here some additional buttons, functionalities. So I could, for example, click here on, I want to have more information. I can mark it as a favorite, but I can also say here, I want to put it into my basket. Those holidays, they come with a filter possibility. So I can say I want to search, for example, for those that start with NOR, then we see it's only Norway. And I can also differentiate between a typical city-only holiday or a complete country, a visit to a country, which obviously takes a little bit longer than just one day. Now, the way how this has been implemented is we have here one holidays component. This is what we see here. As we see, it also works with template-driven forms. And at the very top, at the very bottom, if we come to our component, to our code, we see here no signals. And this is what I'm going to do now. So first of all, we need to be able to use signals for a simple component. So how do I do this? Well, I say I have here my query, and if I want to make it as a signal, then I just call here signal. I put my initial value into it, and then this query becomes a writable of a string, writable signal of a string. So you see signal, just the function call, but you have to provide an initial value. So a signal will always have a value available, will never be without one. The type inference here works very well. As we see, we don't have to provide here the type, but TypeScript just inferred it from this initial value which we provided there. Next thing, we have here holiday type, which is a union type of strings. So if I say here again signal, and I remove the type, because I have to, it's not a writable signal, we are getting here a little bit of a problem, because here it says, yeah, it's a writable signal of type string, although it should be holiday type, but let's leave that for now. Let's also do here the last one, which is the holidays. This is the list of the holidays that are shown once they have been loaded. And I say here again, signal, and I provide the empty list to it. And now we see the problem. Again, type inference works like with any other empty array. It just doesn't know what type it is, and that's why it says it's never. So what can we do about it? There are two options. The first one is that you apply type assertion, which means you say here as, and then you say this is now of type holiday, and it would be that one, type of holiday array. I don't like this, to be honest. I usually go with the other one, where I can make use here of the generic function. So I put the type here. So I say here holiday, and it more or less it ends up with the same result. The question is though, why did I go with that one, and why didn't I stick to the type assertion? With this approach, I in a way define that I say this should be of type holiday array, and then I'm providing a value to it, and then TypeScript needs to confirm or needs to check if this empty array could end up being of type holiday array. If I do it the other way around, like saying as, this is always kind of overwriting the TypeScript compiler. I don't like this. There is actually a video, a very old one from mine, where I'm discussing kind of type narrowing function. If you're interested, yeah, please watch it. And the same in terms of generic types is then also true here. Here I say, okay, this is actually of type holiday type. So again, I'm defining the type that I want to have, and then TypeScript confirms if this all value is all right or not. So this is about how we can generate our own signals. The next question, of course, is how can we access them, or how do we deal with them? So if we scroll here a little bit to the search function, we see first of all the search function is triggered in the ng on init, so that we see already immediately some holidays. And here the search function says I'm using here holiday service find, and it uses the old query and the old type, which used to be normal strings. Now the way how we can get out the value of a signal is that we use the signal as a normal function. We just call it. I have to do the same also to the type there. And the reason why this was necessary, or why we have to call it as a function, was that the Angular team, they did this on purpose. There are different ways on how you can access the value of a signal. But what they said is that they want to make sure that when we call it like a function, that in a way we also are aware that it's not just like a property access. We are doing something internally as well. So there is something which happens if we do that. And if the function syntax is used, then we kind of understand that a function can do something. It's obvious, and that's why they went with it. The next thing is, of course, how can we now update a signal? Because here we have holidays, and I can't assign it. So I can't say here, okay, those holidays which this holiday service provides me, I can't assign the array to it because it's not the same type. But for that, we can go and we can say, okay, I use the set function and I put then the await into it. And of course, I can also say, let's do it like this. I move it out and I say, okay, holidays like this, if this reads a little bit better. The set is not the only function how you can update a signal. There is also another one, which is holidays update. What the update function is doing. So it is it would expect another function, an update function in that sense. And in this update function, you get the current value of the signal, and then it is expected that you provide an immutable value, an immutable change. And this means if I would return here just the value, then the complete reactivity, which we still have to see, will not work. So you really have to provide here always like this cloning feature, or like structured clone. Modern browsers support cloning already natively, but you put this then here inside of the update function. In our case, we don't need it because we say we are not interested about the former holidays. We just want to override it with the new ones. What is also interesting here is the usage of the promise and of the async await, because this is something which is not a common thing in Angular. Let's call it like this. We typically would use RxJS. We would have here an observable where we would try to use the async pipe in the template. And if there is no other way, then of course we would subscribe to it and fetch the value then in that way. Now with signals and its reactivity, and also the requirement, as I've explained before, that the signal is the one data type that ends up in the template, we will see that we will have signals in the component most of the time, or I would say even always. And RxJS is, it will be there. There will be some use cases for RxJS, but I would be surprised if I see it that often in a component. I see the place for RxJS more in the logic layer, so more in the services, and then the services might expose an observable, but They might also expose already a signal, so transform or map an observable into a signal. And in our component, we will then have most of the time a signal. And that's also why for some simple use cases, for simple HTTP requests, we might not need the power of the HTTP client, the power of the observable in that case. We can also go with the old-fashioned await async. I don't want to continue this kind of discussion, RxJS versus signals. This would be a whole new video, so let's postpone that one. Good. So this is the way how I can access a value of a signal. I just call it as a function and I use the set or the update method in order to update a signal. And again, this has to happen immutable. So I really need to provide a new value. Otherwise, I will not get an error message. But this reactivity that the signal will update, will notify its consumers, will not happen. Good. So is there something else we have to change? I don't think so. We now come to the template. So here in our template, we see there is already an error message and it tells me, hey, look, you have here a for loop and you give me a writable signal. What should I do with it? And well, we need to access the value again of the signal and we do it in the same way as we have done it in TypeScript. We just call it. Now you might say, okay, that's easy, but there is something you have to be aware of. There is a huge difference between calling a signal in template versus calling it in TypeScript. The template is something that we call reactive context. This means when a signal is used inside of this reactive context, then this context in a way is updating its consumers automatically. So in this case, this would mean when the signal changes here, it is updating the consumer, which in this case could be Angular or will also be the trigger for Angular's change detection. At the moment, it's a little bit embedded in Zone.js, but I think it's safe to say it will update Angular itself and will tell it, hey, look, there was a change of holidays. You might want to mark me as dirty, and in the future, it will run the change detection. If you call the signal in the TypeScript code here like this, then it's not in a reactive context. In context, that's a one-timer. You just access the value now and that's it. And of course, it also makes sense because we don't want that this kind of function or whatever we would see here maybe as a reactive context is executed whenever the query or the type changes. Good. Let's check if there's something else which we might miss. Yes, here ng model might also be a little bit interesting, but I would say let's first go back to the web page and see if it's still working. So if I say here enter, yeah, that looks very nice. So we didn't destroy everything, it's still working. We are now working with signals. About this ng model. I mean, as I said before, we are now running on 17.3, but if you're using a different version, so before 17.3, you might have an issue with this kind of syntax here, the two-way binding, the banana box, where a signal is involved. So usually this should not work, because normally we have here a property binding part and then also an event binding part, and the property binding part, this one, will not work. Because again, we would not assign here the value to the ng model, we would assign a signal to the ng model. And if I go back and reload the page, we see that in the input there is a strange value, because it's a signal. So what we have to do is that we have to call it, that we would have to call it. And then when it comes to the changes, so when I say here the input has changed because I have typed something in, then I could use this event here. And I could say, okay, query set $event, and this would then update the signal as well. This used to be the way how you had to do it until 17.2. And with 17.2, this banana box style was upgraded, and it also now understands the signal type. So if it sees that there is a signal there, if we assign a signal to it, then it's doing the code that we see here automatically. For us, it's just the old banana box syntax, so just type it in like this. Of course, don't call the signal, that's important. And now the rest is done for us by Angular. Right, now we have our search again. Good. So what else? We have, of course, now the power of reactivity, which we haven't seen so far. But let's say we want to show the amount of holidays we have found, and we might also want to print out the query in a nicer way, in a user-friendly way. So I would say here, pretty search equals, and this would be query. Let's use these ones. These, I would access here the query signal itself. Yeah, we know now how to do it. And I would say with type, and then this type, calling it as a signal. And I want to have a holidays count, where again, I would say I'm accessing my holidays, and I want to have the value from them. The pretty search and the holidays count is something I want to use now in the template. So I go here, and I say I have here a div with 2 paragraphs. In the first one, I just say pretty search. In the second one, I say holidays count. And maybe also a little bit of a more user-friendly text. Holidays found. Like this. Good. So I think, or I hope, you aren't surprised if I tell you there's no reactivity now. So if I type here something in, maybe not, like an N, then we see some holidays. It still says 0. We see here an empty query, although I have just typed in an N. That's not how it works. But with signals, we can now say, I want to produce now another signal with some dependencies, which should then produce me the pretty search and also the holidays count. And the second command, there are 3 of them that you have to know when you want to use signals, is the computed. So with computed, very easy to use, I can say, hey, look, I want to run this kind of function where I'm accessing these 2 signals, and I do the same with the other one with the holidays count. So I also say here computed, and add then this formatting function into the computed itself. What computed now is doing, first of all, it's quite a smart implementation, because we don't really need to tell the computed explicitly what kind of signals we want to listen to. It just finds it out on its own. So we just need to call the signal, then the computed knows that we want to listen here for query and type. Computed is another signal. Yeah, so we see your pretty search is now a signal of type string, and the same is true for holidays count as well. And this is now reactive in that sense, and that's now very important if it's used in a reactive context. Yeah. So just by using computed, you don't have a reactive signal there, you still have to use it in a reactive context, and by now we only know one, and that's the template. So this means, to put it short, if I would call the pretty search somewhere in my TypeScript class, it would have no effect. It would give me the value back, which it has right now. Again, it's a signal, it always has a value there, but not more. So it will not re-execute if the query, for example, changes. Yeah, and I think it's also, I hope it's obvious that it's not a writable signal. What should I write to a derived signal? I have to write to query and type, yes, but not to pretty search or holidays count. Since it's a signal, I also have to use it like a signal. So I have to go here back to my template and I have to call it here. So I have to say, yes, you are a signal. Please now also behave like one. And now I'm putting the signal into the reactive context, which means again, if now pretty search or holidays count, if one of their producer signals change, they will again notify Angular itself and will say, hey, look, there was a change. You might want to update the DOM. Yeah, so holiday is found 13, and if I type something in, we see immediately here the feedback, so that it updates automatically. Also here, of course. Good. The last thing, I said before, there are 3 of them. The last thing, of course, is now the side effect. So what's missing is, I've now said multiple times, the reactive context is the template, but still, what if we require something like this reactive context in TypeScript, in our TypeScript class? What do we have to do there? And for that, we have the effect function. So the effect function is exactly that part which gives you a reactive context in for your class in TypeScript. The way how we do it, let's say we have here a constructor, and there I have to say effect, like this. It works exactly in the same way as the computed, at least from the syntax. Internally it's something else, because it's reactive context. We say here pretty search, I call it, and I say log. And this should now mean that whenever I change something here with the pretty search, that I also see here the output in my console. So if I type here something in, we see the output is immediately there. If I change something in the type, then it's also there. With this kind of reactive context that we have, there are of course some requirements. How often does it run, or how long does it live? This how often does it run is something for later. More important thing now is how long does it live? And Angular does this for us automatically. So where we had in RxJS the subscription, we also were forced to use an unsubscribe. In Angular this is done automatically, but there's just one requirement. We have to use the effect function in the right place. If I move it to the engine init, and I'm now rerunning my application, then first of all, we don't get a compilation error, but what we get instead, you see it here already, it's a runtime error. And the reason for that is that the effect is not running in an injection context. Why that? Well, because somebody needs to close this reactive context, and if we don't do it, then Angular has to take care of it, because otherwise that one will live forever. And the effect automatically tries to grab the current injector or the current injection context, and then also is destroyed when the current injection context also gets destroyed, and the current injection context is the one from the component. So it gets away, or it gets destroyed with the component itself. We don't need to do anything. We don't need to call it explicitly. As I said before, we just have to make sure that the effect is in the constructor, or if you don't want to put it into the constructor, you can also do it here when the fields are initialized, but then of course you need to assign the outcome of the effect to a variable. Yeah, you can't do that much with a variable, with this ref variable, but that's just the way how you would have to do it outside of the constructor. There is a third option, but I wouldn't recommend it. You could put it into the engine init. You can then put it wherever you want, as long as you provide the injector manually. So if you say here injector, and you, of course, you need to provide now the injector, you need to get it from somewhere. So you could say here inject injector, like this. And if you then say here, please take this injector, which I already have, then we will see that now the effect is also working. Okay. But of course, again, I would say don't start doing these things. We still, patterns for signals are still evolving, but it's already very clear that this might not be the best choice. This might not be the best pattern that you should use. So please, as I do it, put it into the constructor or use the effect reference. Much better. Okay, so I think we have now covered the signal function, the computed function, the effect function. We have also covered the term of reactive context, where I said it's the effect or it's the template. And we have also seen how the signal computed, how they behave, how we can access a signal, and so on and so forth. What's also important, the banana box style also works now with the signal as well. And I think that this is it for the very beginning. This ends the basic unit, and we are now ready for the more advanced stuff. So we come now to the advanced part, and there we will discuss things like the glitch-free effect, like the dynamic dependency tracking, and also things you have to be aware of when you use the effects function quite often, especially in combination with calling other services and that stuff. It is not really important that you remember or understand everything in detail, but you should be aware of those kind of behaviors that I'm going to show you, because you will definitely stumble upon them, and then it's very important for you that you know that everything's all right and that it is just as it is supposed to be. Let's go back to our application. And let's just say we have here some kind of search. So I say here H, and I click on enter, and we see that all the time. Whenever I type something in, we get here a query in the console, and that's coming from this effect which we have here. Now what I'm going to do now is that I'm going to change my effect, and I say whenever the holidays are updated, then I want to print them out. So I say here holidays, and I say okay, access my holidays, like this. If I now go back, then we see that here the holidays list is always shown. Good, and now I'm starting to do something very strange. I go to the search function, and I say, before I'm setting the new search, the new holidays, I say first of all they are empty. That's not enough. Then I say okay, I create now a new holiday. Can do this with the create holiday function. I also need to add here a certain property, which is favorite. I say no, it's not favorite, and I'm running then the update function, because then I might have here a use case where I say I'm kind of doubling the entries of my holiday array. So I say here value, and then another time value. And then again, because I'm funny, or I think it looks that interesting, I'm again updating my holidays. So what we see here, that we have 5 updates of my signal. And well, we would of course now expect that we will see now quite a lot of console logs. So if I now go back, nothing happens. Of course, I didn't do anything in terms of search, but here we have just one. So if I remove everything which we had so far, and if I now type in Vienna, it's just one. I say E, now it's 6. Okay, then we see 6 holidays. What's going on? We could now say, well, maybe the signal doesn't have the value at the moment. Well, we can try this out. So I can say, okay, what happens if I do here a console log where I say, okay, I want to show here the holidays like this, 1 time, 2 times, 3 times. Maybe they are not there, or maybe, I don't know what is possible. So I say here again, B. Then we see 1, 2, 3, 4, and then the 5th, which is the final update, of course, it shows up, and we also see here that it contains those values which are supposed to be in the holidays. But our effect looks like it's only aware of the last holidays that we have there. Again, Vienna, we only find 3. It's only here the last one. That's the glitch-free effect. So the best way, at least for me, how I understood it, and also the reason why we have it, which is more important, is if we see the signals from the perspective of Angular. Because Angular says, I want to have a data type where I can provide an optimized DOM update, an optimized rendering. I mean, we shouldn't use the term rendering together with Angular, but you know what I mean. And if we think about it, about this use case here, if we would say, well, every signal change should result in a re-execution of the change detection, updating the DOM, it doesn't make any sense here. Because how should this work? We have here set. And then I say, okay, stop right now what you have done. I don't continue. I now go to the DOM and remove all the holidays. Then the next code here is executed where one holiday is added. I say stop again. I now need to go to my DOM and I need to add here this holiday card, and so on and so forth. These changes, these DOM manipulations will happen so fast that we don't even see them. What we see though is at the very end that this holiday is coming from our endpoint set. So it's not necessary to start here all the change detection, to start here the DOM update, if I know it's already changed in the next split millisecond or so. And the glitch-free effect guarantees us this. The glitch-free effect says, I am only going to activate or request the data from the signals if I'm running in the change detection, so if I'm running asynchronously. And only then will I take the last value that I have, or the current value. And this also has an impact on the computed and on the computed based on computed and on the effect, because they will only run once in the change detection. And that's the reason why the change detection, when it runs, when this search here is over, Zone.js kicks in, and then Angular says, okay, give me now the value, or everything has already been executed, and now the effect says the same thing. So the rendering starts only with the last holidays, and the effect also only gets the last holidays. And if there would be some further signals involved, like a computed, it would be the same for them as well. So for example, if I would say I have here a computed of holidays found, and I do something which you shouldn't do, that you say here, hey, from computed would be a side effect in this case, then we will also see that this also only runs once. So if I now go back, and if I say here v search, then we see hey from computed. Of course, the effect here is also there, because again, works in the same way. So if you really try to understand it, to see it from Angular side, then this is just natural. It has to be like this. This is very efficient. Why should I update the DOM in a split millisecond if this is actually technically possible, because the browser will not even render it? Yeah, so that's the way how it is. There's of course there's also a consequence out of this behavior. You can't expect that every change will be processed by an effect. So if you want to implement something and you rely there that every effect knows about the changes of the signals, then you will not be very lucky here. In that case, or in these cases, you should definitely go and use RxJS for that. So this would then be done by RxJS, but in the end, again, we want to render only the necessary parts. We will map the observable to the signal. And before I remove that code, there is one important question. What happens if I move the set here before the first await? What does this now mean for the effect? Will it now be executed only once when the holidays are set, or will it be executed first with an empty array and then second with the holidays? Let's try it out. So we need to wait until the page is reloaded, right? And then I say here Vienna, click on enter, and we see 2 times. And again, from this kind of explanation from before, it hopefully makes sense. So I click on search, the holidays are set to empty, and at the same time or right afterwards, I'm starting with an HTTP request. Now, why should Angular wait until this request comes back? It wants, of course, it needs to render now, because it says, yeah, now I'm running the change detection. And it will then say, okay, these holidays have been set to empty. We don't know about the rest. That's asynchronous, will happen sometime later. So this first one will then be triggered, or will then be processed by the effect and also by the template. Then the response comes back, which is where we are there, and they all run asynchronously. And then only the last one will be taken into consideration, and that's why we see then only the last execution. That's what this glitch-free effect is all about. So I have here again, just for summary, there is here an animation. So we have here some kind of caller. This is the reactive context on the right side. The caller goes to in this case, it's a computed. It requests the value. The computed executes its internal function. It activates the signals, its producers in that case. And at the same time, the computed also registers itself as an active consumer. And when those producer signals are accessed, so producer signals is just another term for the relationship. It's a normal signal. So there is no type like producer signal. But if those producer signals are then accessed, they will first of all look if there is an active consumer there. And if that's the case, then they will store this active consumer internally. And of course, will send the current value back to the active computed. The computed will do the processing and then will send it back to the consumer, to the reactive context. Now the producer signals are now aware of their consumers, which means when the next time one of those signals, producer signals, are changing, then they are notifying their consumers that there was a change. But this doesn't happen, or this doesn't mean, that these consumers are now starting to do the processing. They are just remembering, the computer remembers that it is, in that case, dirty, which means it knows when somebody accesses it the next time, it has to do this internal processing. So when this reactive context comes around, second time, which could be another change detection run, very likely this is the case how it is these days, then Angular will go to the computed and will say, do you have a new value for me? And since the computed knows it's dirty, it starts to do its processing and then it sends the last value back. Because obviously, with the processing, it starts requesting the producer for their current value, which in this case is what we see here in line 111. And it will use only that value, and this is what the consumer will also, or the reactive context will eventually get. This kind of glitch-free effect, because of that, is also called the push-pull principle, because the signals the producers push to the consumers, but the consumers still depend on the reactive context, on their callers, that they actively pull the value from them, and only then do they start their internal processing. Good. So now, where we know what's going on here, I can remove it. And let's leave it as it was initially, like this. Now we'll take a look at something else, which is called the dynamic dependency tracking. What is this? Let's say we are extending here our effect. Let's say I say here at the very beginning, running effect, ... And I say here log, and I say, okay, I have here an if condition. And I say if this type equals all, or maybe not, let's not put the type in there, let's put the query in it. And let's say if the query equals Vienna, then I want to console log a second time. This type, okay, I have to do it by the shortcuts. Obviously, I'm unable to type in the console log. Good. You might not say, okay, what's the speciality? What's so special about it? Well, we see here a running effect, which has now a conditional dependency with type. This is the special thing here. So something which changes now, because if I type something in, we see the running effect happens all the time. Yeah, that's true. But what happens if I click now on these buttons there? Well, the pretty search changes, but we don't see here this kind of running effect. Yeah, obviously, because we have to use Vienna. And now all of a sudden, if we click now here between the holiday types, then we see that the effect is now also executed along the console log for the city or for country. Now the interesting thing is, If I'm going to change Vienna to remove the A, it's not Vienna anymore. And if I click here again, no console log. If I add the A, there is a console log for the holiday type. Very strange, but the way, again, how this works, and this is this kind of dynamic dependency tracking, is that with every execution, the effect in this case checks if it actually requires those producers anymore, which it has maybe saved from a former run. So when query is Vienna, then we would go here into this if condition, and then all of a sudden this kind of subscription to the type signal shows up, and then in the third run, the effect goes to the type and says, hey, I also want to have this kind of information from you. I'm also now your consumer. Of course, and the type is registering the consumer and will then, of course, update it. And this happens dynamically, but also the unsubscription happens dynamically, because if it's not Vienna anymore, then obviously the effect would have to go to the type and would have to tell it, hey, look, I'm not interested in you for any reason, or I don't know the reasons. This is dependent. This is implementation specific, but just please remove me from your consumers list and don't notify me anymore. I don't want to run the console log there. Again, this comes. It might look strange, like the glitch-free effect, but this is something which is, first of all, very good, and in terms of contacting, updating the DOM, very efficient. Because why should something update when the type updates, when I'm not interested in the type anymore because my conditions have changed? So it's really a dynamic change of the dependencies, which is built in, and we don't have to care about them. We just provide our code, our conditional code in Angular, or the signals will do the rest for us. Good. And now let's do something strange. Let's say I say here const query, this query. And now for some reason, I mean, this is not so unthinkable actually. I would say if the query is Vienna, then I want to say from now on the type is of type city. Now I can do that. So I go back, everything looks all right. I say V, I search, wonderful. But now I type in Vienna. And then we see all of a sudden we have an issue. Because now what Angular has detected, that there is a circular dependency. It says, hey, wait a second. You are an effect. You are on the outer end. You are not allowed to start updating a signal, because then the signal might trigger another kind of notification cycle, and that could go on and go on. So we could end up here in an infinite loop, and that's why Angular by default says this might not be what you really want. But there is something where there is a feature for it where we can disable it. And there are definitely some use cases where we have to say we have to disable it because there is no other way around the effect. We have to use the effect in order to update another signal. So what we have here is that we can say allow signal writes, and then we set it here to true. So if we do this, and if I type then in here Vienna, we see it changes back to city. Yeah. And if I then click here on all, and if I type in again Vienna, it switches back to city again. What happens now if I say I don't care about Vienna? I say update it always to city, like this. Would we have now an infinite loop? So I can type something in. We see that for some reasons, obviously, the all is not updated anymore, which is strange. Type city. Oh, sorry, we are setting it to city. Then let's say here all, sorry, my mistake. And then I type something in, and then we see as soon as we do this, it jumps back. Good. The interesting question now is, does it now update the city all the time, or is there some kind of protection for an infinite loop? We can try to find it out. Everything that I have to do is that I have to come up with another effect where I say, hey, I am afraid that this type there is updated all the time. Please log it out once there is a real update going on. And then we will see if we are in an infinite loop or not. So we have here the first update of city. I say, okay, I'm typing something in. I say all. It is now saying all, obviously, because it has changed. Typing in another letter, it jumps back to city. Another letter, nothing happens. Why that? I mean, the query has just changed. I have now typed in another letter. Well, the reason is immutability. I explained it before. City is a string value. It's city. It was city. I want to set it now again to city. And then internally the signal says, what do you want to do? I mean, this is the value which I already have. Why should I update? Why should I notify my consumers about this change? It's the same value. Nothing has changed. So it's not an infinite loop in this case, because we are always overwriting. We are always setting the same value. Nevertheless, be aware that these things exist. Be careful about them. Be cautious. And if there is a need for it, then of course you can say allow signal writes. There is now something else. You can also start to trigger here for some reason another signal, or you can open up a reactive context for another signal here without even knowing it. And this usually happens in the effect, obviously, and this happens when we are calling here some kind of functions. So if I say here, I don't know, I want to say here when the query changes, I want to print out maybe the type again. Then I would say, okay, print out search. And what that one's doing, it just says, okay, pretty search, print out the log. So I start here by saying, let me remove that one. Now I start now by saying here, I want to have the query. I want to have some kind of an implicit subscription to the query. And whenever the query changes, I just have to call it. I don't even have to assign a value to a variable. It's just the calling is already enough. Then I say pretty search, like this. Print out pretty search, sorry. So just call another function. Happens quite often. You might be surprised how often this works when you use signals in real life. And if you now go back, and if I now type something in, then we see here query with type all. The problem is, if I click here on city, if I click on country, then for some reason, the effect is now also executed. And the reason is that although we didn't open up here the query in the effect directly, we call the function, and the function call was inside of the effect. And that's why the pretty search, and not just the pretty search, but also all the signals which the pretty search is using, the query and the type, were also included in this reactive context of the effect, which means when the two changes, this effect is also executed. And of course, it's also dangerous when a signal is updated there as well. So for these use cases, the pattern that we see is that we use the untracked function. So we have two parts of the effect function, where in the first part we would say, here comes the subscription. Subscription, it's not, we shouldn't call it subscription, that's an RxJS term more or less, but nevertheless, we have here those kind of accesses to our signals, let's call it like this. And then we have here in the second step, the processing. And the processing, if we say it should not trigger any side effect or start with a new it shouldn't listen for any further signal changes, we use the untracked function. So we put it in here, and then we can say here print out search, this is safe, and whatever happens now in printout search will not affect the effect. Let's try it again. So I say here, okay, I have here some kind of a query. They will all print out, that's fine, that was expected, but not if I click here on city. Yeah. Then we see the city country, that's of course coming from this effect, which is still there, but if I remove it, then this printout search will not have an impact anymore. Yeah, so I can then switch between here and only the console log happens there. As a nice side effect, you can also then say you want to update here a signal. That also works. So if I say here this type set it to city, and I do this in an untracked function, then it will also not cause those kind of issues that we have seen before. So if I say here all, and if I type something in, we see it switches back to city. Yeah, so we will see, but this kind of untracked function is something which is very important. Please remember that. You will definitely require it. The effect function is, the moment is still in developer preview. We will see if maybe there is not an additional change coming which deals with this kind of things a little bit better. There have been some discussions on GitHub where some people, including me, kind of suggested that maybe we want to do an explicit signal tracking in that case. Yeah, it didn't happen, but what the Ingra team did is that some of their internal APIs, when they are called inside of an effect, that they are untracked automatically. Yeah. So we can do it automatically in this case. We can also do it on our own if we write those effects ourselves. That will work, and I will also recommend you to do it. So whenever you see an effect, please think about the untracked part first, and that you are on the safe side. Yeah, and that was the advanced part. And now we will take a look at the RxJS interoperability part. So now about RxJS signals. First of all, maybe some kind of background information, because some of you might ask yourselves, well, what you have seen so far with signals, this is something which is very similar, if not the same, that we can also do with RxJS. Maybe with RxJS we can do way more. Yes, true. But why use signals? Why not? Why did we actually have to invent, or why did the Angular team actually bring in signals? The reason is that, first of all, maybe RxJS is a little bit hard to learn, but there are some things which you can't, or which is you would have to go with a compromise in order to achieve it, because this kind of K-tree effect that you have seen before, that's very hard to implement with RxJS. You might come up with special pipe operators, but in the end, so this pipe operator would say, I am blocking until the change detection runs, and then I'm taking the last value out of it. But you have to be able to make sure that this pipe operator is used everywhere, which is not easy. And then the other thing is, of course, the signal always have to provide a value, and an observable doesn't. Observable can produce multiple values, but if you ask it at the very beginning, maybe it says, yeah, there is no value yet, you have to wait. What should Angular do then? So if I'm a rendering engine and I say I want to start rendering now, and the observable tells me I don't have a value, wait, maybe in 2 seconds you will get one, that's not an option. So that's also a reason why signals are there, but we still will have some use cases where we use RxJS, and that's why it's important to know how to jump between RxJS and signals, and there are some functions for that from Angular itself. So let me quickly start here by saying I have, let's say, a pretty date, and I use for that a signal. So I say here, not a signal, but an observable. So I say in the beginning, the pretty date is a string, and in my constructor, I say, okay, I have an interval where I emit every second. In this interval, first of all, I want to see something. So console log, tab-driven development, as it's also called. And then I say I have my subscription, in this case, where I get my value, or I'm not really interested in the value. I just say this pretty date equals new date to local time string. Of course, you could now say, hey, wait a second, why do you use a subscribe? Please go with an observable. Would be possible, but in my case, I decided to go like this. So how do I use the pretty date? Well, I just say here in my template, here we have already some space. I say here pretty date, and it's not a signal. So if I now go back to my application, we will see that it runs perfectly fine. So here we have our current time. Now, the thing is, and the reason why I used here the subscription was the unsubscription. That's always an issue. So if we are dealing with observables, we always need to find a way how to properly unsubscribe. Now, if you use the async pipe, we are always on the safe side, because with the async pipe, Angular will do the unsubscription. But we can now, and this is the first of 3 elements from this interoperability library, we have now an operator where we can also do it if we subscribe manually. And that one is takeUntilDestroyed. Yeah, so if I save it now, let's do something else before. Let's rerun it, because the problem obviously here is that this interval is continuing. So this is now this kind of subscription problem which we have, is the interval is still continuing, although I have already left my component, and it gets even worse, because if I enter the component a second time, a second one starts. And this is why we need to use something like the takeUntilDestroyed. So here I say, okay, whenever the component is destroyed, then I also want that this observable and therefore also the subscription ends. So if I now go back, we see the console log is printing out the numbers, but as soon as I go to home, it stops. And if I go back, then it starts, of course, again, but now the other one is not there anymore. The takeUntilDestroyed works in the same way as the effect before. It is only possible if it has access to the current injection context. Otherwise, it will fail again. So if I would say here, I'm taking here this interval and I move it into my ng on init, then we will have a problem. Not because of the observable, but because of this pipe operator there. Yeah, you see, takeUntilDestroyed can only be used within an injection context. That's the problem. Good. There is, of course, one option. You can provide the so-called destroy ref, not the injector as it was in the effect, but here the destroy ref manually. The way how it works, destroy ref, I'm requesting it here via the dependency injection. I say, yes, this is the destroy ref, and I'm providing it here as a parameter. And now everything's safe, because now I can say, okay, the takeUntilDestroyed knows now when the component is destroyed, obviously, and if I leave it, the unsubscription also happens. And you've seen it before. This is safe. So as soon as you use the takeUntilDestroyed, you will get either a runtime error or it will work. Good. But now we want to move on. So what we want to do now is that we want to say, it's nice that this is an observable, but I want to have a signal out of it. How do we do this? So I say here this pretty date actually should become a signal. So I say here interval, I'm assigning this interval to it. I still have here my console log. I don't need the takeUntilDestroyed, that is not necessary anymore. And I also can't do anything with the subscription here. I need to produce the value like I would do it with any other observable, namely with the map operator. So I say here, okay, I have my map, and I then just say, okay, new date and to local time string like this. Another problem is, how do we get from the observable string to a signal of string? Well, we just say toSignal. It's as simple as that. Yeah, I say, maybe not. So first of all, the pretty date is not used as a signal in the template, so we call it like one. We save it again. And then Angular says, from my side, from TypeScript's perspective, everything's all right. I would be able to render it. But we see that the pretty date is a signal of string or undefined. And this is something I don't want. I want it to be a signal of string. And the reason again comes from the observable. Because the observable doesn't give us a guarantee that it has, every time we access it, a value. So we have now two options. We can say, it's my responsibility, but I now say, require async, sorry, not here, but here, there is an option for that, require async true. And this now really means, as I said it, if something fails, then it's my responsibility, which means we will get a runtime error. So if I now go back and if the page loads, we see here now a problem that, here we are, that now Angular says, well, you said it is a synchronous observable, that the value is there from the very beginning. It wasn't, and that's why I'm throwing here a runtime error. So maybe that's not the best thing that you can do. A better option would be that you just say, okay, I am providing an initial value. In this case, it's the new date to local time string, and then everyone is happy, nothing will happen. And in case the signal or in case the observable emits immediately, it's also not a problem. Yeah. Without runtime exception, and the nice thing is, of course, also the unsubscription from this internal observable also works. So if I go back to home, then we see here it stops, the counter is not increased anymore, and if I go back to holidays, we restart again from 0. And for obvious reasons, the same is also true for the other way around. So I could say, okay, I have here my pretty date, and I would say here, I would get from this existing signal, I want to have now the observable version of it. So I say here pretty date with $, and then I can go back to my async. Where do we have it? Pretty date, $, use the async pipe, and it's the same. Pretty date async. Did I use the pretty search? Yes, sorry. Should be pretty date. Yeah, now it's working. Pretty time is actually a better term for this, but we see no issues. And also if we go back, then yeah, the unsubscription of course also ends or also happens. And that's it. So these are the 3 functions which are available already since Angular 16. The takeUntilDestroyed, the pipe operator, the toSignal, and the toObservable. Okay, so with Angular 17.3, we have this new API available, which replaces those functionalities which were responsible for the component communication. And that was the input, the output decorator, but also viewChild, viewChildren, contentChild, and contentChildren. The new API replaces them with normal functions that in most cases actually except the output always returns a signal, and of course everything's backwards compatible, so you're not forced to use the new API, but if you want to make use of the advantages of signals, then of course it's highly recommended. And we are going to use them now in our holiday component and also in the holiday card, which is a subcomponent of our holidays component. So let me switch to the holidays component back again. And well, let's start with the viewChild, because here we have a use case for it. I say I want to access the ng form because I want to first of all verify if the ng form is valid or not. And if it's not valid, then I don't see any reason why I should start with the search method. So I say here I have a required attribute, and I also have a min length attribute, so I require at least 3 characters. Now in order to verify it, I now say, okay, I want to have access to the ng form. So the way how this used to work in the past, that we had a viewChild, and I said ng form, this is the type that I want to have. And since I only have one form element in my template, I can also use the class itself. Now we see already the problem. TypeScript says, no, that's not going to work. You can't just say it's an ng form, you need to initialize it. So in this case, I have to say undefined. And of course, I don't do this. This is forbidden, or it is not forbidden, but if it would be up to me, I would not allow it. Let's put like this. So what do we have to do now with this viewChild? Because it is undefined, we have to find a way how to access it safely. So I can say here in my search, of course, that I say, yes, there is this ng form, and I know it could be undefined, but I want to know if the form itself is valid, and then do I want to start with the search itself? Which means at the moment the engine init starts the search. It's not available. A viewChild run later, which means we shouldn't see any holidays. So if I go back, this is exactly what we see. I can reload them, no holidays are shown. Good, so what can we do? We can use the other lifecycle hook, the after view init, but there is a modern approach which we have already since the major 16 of Angular, and that's after next render. So this is a function that we can call one time after the rendering was completed, and it is called not a lifecycle hook of the component, it's an application hook, because we could also use it, for example, in a service. It also requires the injection context. By now we know why this is the case, because of the unsubscription. So the after next render, if we run it in a component, we don't want that it continues to run once we leave the component, so that's why we have to run it in the constructor. So I say here after next render, and I say, well, once this is done, once the rendering is finished, I say please search, please start the search. The ng form should be ready and we shouldn't have any issues. I can remove it here. I can also remove the ng on init. It's not necessary. The other one is now taking over like this. Let's see what happens. Ouch. It works. We see at least the holidays, but we have here this expression has changed after it has been checked error. And if you remember in the very beginning, I said that signals will remove them as well. And by now what we know about the signals, it's also maybe understandable the way how they do it, because the signal access only happens in the change detection. It means it doesn't really matter when before the change detection runs some parts of the properties or the signal changes multiple times. It doesn't matter because that won't have any effect. It's always the last value that counts. This also means that this error has to come from something which is not a signal. And it says here loader component, and it's a good opportunity maybe before we continue with the viewChild that we might want to refactor the loader component to signals as well. Because until now we have only seen signals, how they were used in a component, but it's not forbidden that we use it also in a service. So I go to my loader component, and there we see we have here this loading and observable with an async pipe coming from the loading service. So, okay, good, sounds good. Let's go to the loading service, and here we have our behavior subject, the observable, and we say whenever I start with the loading, I call start, and once I'm done, I say end or stop. And this should now become a signal. It's as easy as that. So in our case, we say, well, we have here already the behavior subject. So from the patterns, from the signal patterns, it's the same. Behavior subject gives us this guarantee that a value is every time available. So I just have to say, okay, now I have my new loading. It's now a signal of false. So by default, we are not loading. And to the outside, I will expose normal signal, a read-only signal in that case. So I say here loading, and I say as read-only. Don't need the dollar there. And when somebody says, I'm going to start loading, well, then I just say, okay, loading, set loading set to true. And I also need this, of course, then here in the stop, where I would then say false. Yeah, and then I need to go back to my loading component where this error has happened. And I say, well, loading is now a signal. Just call it and just check if it's loading, then say visible is true. Otherwise, say it's hidden. The Angular application compiles. We go back to our template. We reload our holidays. And we see no runtime error anymore. The signals have removed those kind of things. Good. So now the loading, the holidays component is working again. So I can go back, and we still have here our viewChild. And in this case, we can now say, okay, we want to use now the new API. And the new API says, okay, don't need the viewChild decorator anymore. What you do now is that you just say viewChild. Call a function where you can say this is required, and then you just provide me the value, the class that you have done in the past to the decorator. So very simple. So I say here ngForm, and you see that this is required is now something which is really great, because with the required I get rid of the undefined, of the union type with ngForm and undefined. That's now only a signal with an ngForm. Careful though, this comes again with a requirement. You are not allowed to access the signal before it's internally actually available. So the same rules apply as they have done before. If you access this ngForm, maybe in the constructor, maybe in ng and init, then you are too early, and then it will fail. So if I say here in the constructor, maybe wait a second, the form can go away, or it should go away. Yeah, you have to call it, of course. Now it's rebuilding. And if I say here in the constructor, I want to access now my ngForm too early with lock. So I need to really access the value. Just using ngForm doesn't have any effect. And if I now go back to my application, we will see now an error. Because now it says, hey, look, this view query was way too early. You have to do it differently. Because it is a signal, we have ways on how to react on it in a proper way. We can say we want to run a side effect. So the search could be a side effect. But we can also say we want to, maybe in this case not, but we could also run a compute it for it. We have those functions there. We don't need to introduce new lifecycle hooks. We don't have to learn them. We also don't need to know when this signal has now a value. We just say, look, we have now an effect, and I say, whenever this ngForm's available, I want you to run the search method. This is what I want to do. I don't need to after next run anymore. It's nice that we have it, but we can also do this with an effect. I'm now going to remove the validators that we have so that the search always works. It also starts with the holidays first. Let's see if that works. Writing to signals is not allowed in the computed. This looks like now a familiar use case, a familiar error. And if you remember, I explained that before, where I said, hey, maybe be careful whether we have it when you have an effect that always kind of is a little bit sounds like trouble, smells like trouble. So just go here with the untracked function, put here the search in it, and then we should be always on the safe side. Yeah, and in this case, that's what happened. So again, you have seen it with the effect. Careful when you call a function. I would just recommend by default always add an untracked to it. And before you do it, define here explicitly those kind of signals that you want to react to. So my holiday component uses an app holiday card as a subcomponent in order to visualize the holiday itself. And as we see here, this app holiday card contains an input with a holiday, 2 event emitters. In the problem, we know this already, the input requires it to have an assigned value, or it has to be holiday or undefined. Now with the new API, I can say I'm going to remove here this input, and as I have done it before with viewChild, I have a function where I say input, and this function now gives me 3 different versions. The first one is that I could come up with an initial value. In this case, if I provide a string, the holiday is a signal of type string. I can also say it's of the generic type string. Then this would be a signal of string or undefined, what we had before. Or I just say required and say it should be a string. Then it will be an input of type string. And the same rules apply now with what we have seen before in the viewChild. You have to make sure that you don't access this signal before it's there. And again, if you do it in a computed or if you do it in a reactive context, like the effect, like the template, then you're always on the safe side. Otherwise, you are running you have the risk that you run into a runtime error. And the same also what we had with the viewChild. It's now it was the ng-form, which was then a signal of ng-form, and with input we have the same thing again. The holiday now becomes a signal. Again, remember, let me quickly switch this to a holiday. Remember what I said in the beginning. When a signal component comes, the signals will be the one that trigger the change detection. So we have to make sure that everything that we use in the template is a signal, because otherwise we might miss some DOM updates. So if I now go into my template, we see here some kind of issues. This is something from the past where we had to access or request if the holiday was actually a holiday and not an undefined. I don't need this anymore. And in my template for the holiday here, I can just call it, it's a signal. And I could not say if holiday, call it, and then as value, or I just call here the holiday multiple times. I think I will go that path. So I'm done. Maybe not the best choice, but the problem that I had with the other approach would have been, you can say if, you can say you call just the holiday, and then you have here something where you say, okay, what do you say now? It's holiday. Is it now the value? Should I also store it under holiday, or should I use value instead? Yeah, we don't know. We don't have, unfortunately, no conventions for signals. With an observable, it would have been $1. It would have been easier. But here, yeah, we will have to find something out in the future. For us, the important thing is it works. So the holiday card at the moment is saying an input required of holiday. And if I go back, we have this kind of safe access to our signals because we are using it inside of the template. What else? We have an output. So what we applied for input, we can also apply now to output. So I can remove it here, here, here. And I say instead of a new event emitter, I just say you are now an output of type number. Like this. And to the outside, nothing changes, except we have to use now the output a little bit differently. I mean, a little bit differently, not really. It still has the emit method. So let's quickly go to our template. We have here remove favorite and we have here add favorite. The output is still this kind of provides still this emit, and to the parent components it's still an event. So nothing has really changed here, except that the output does not have this kind of binding to RxJS anymore, and it's not a decorator. Why is the output not a signal? Well, because it's an event, and maybe putting a signal together with an event might not be the best choice. We have also seen this, by the way, in our holidays component as well. So here we had this search function, which, where do we have it? The find didn't return a signal of holiday, but it returned a promise of holiday, but we used the signal as a container for the final result. So this is the way how you can do it. If you don't want to use RxJS for more complicated use cases, there will definitely be here an observable, but for this, it's enough if we say this is a signal and we fetch the value and put it into it. But for output, it's an event, so there is no, it might not be the best option to return here a signal type. Good, so this is input, this is output. Are we done? No, we are not done. There is something else I want to show you. Let's just say we have here this kind of basket. There it is. So we can kind of put this holiday into a basket, and let's just say we can only do it for one particular holiday. Now, in my holidays component, I say I have here a basket, or I say this is the selected holiday ID, and I say it's the ID is one, which is in our case the Norway holiday. That one's now selected. And I also want to print that out. So I say here, where do we have it? We say here we have another paragraph where we say selected holiday, selected holiday. It's not a signal, but this will change. And yeah, now I want to provide this selected holiday to my app holiday card. So I say here, okay, you will now get, or as just a selected. And I say you will get the value from selected holiday ID. By the way, if you're wondering why I have here this kind of errors, that comes from a former version of IntelliJ that doesn't, or at least now it doesn't support the new output function, but that's going to change very soon. Good, so I say here I have selected. We know by now how this is going to work. We say we have a required of a number. And what I'm going to do is that I will say now, if my holiday ID is the same ID as selected, then I want to bring up the red background color or something like this. So I go into my component there and I say, yeah, maybe here, ng style. Yes, I want to import that one. And I say if the selected equals holiday ID, then I want to return background red or BG red. We will see it in a minute. And if not, then yeah, it's just nothing. And I also have to put this into an array. Let me quickly check what the right CSS class is. BG, is it red? Yeah, BG red. Is there a 5? It's just a red. Let's use a 500. As most of you will probably know, it was the wrong directive. So it should be ng class and not ng style. Sorry for that. Good, let's go back now. Let's retry it again. It's going to work. So here we have now Norway. What's missing? That my holiday card now needs to tell my holidays component if somebody clicks on this shopping icon here, because now it should switch from Norway to India. So we need an event. Going back to our holiday card, I could now say, well, selected change. I say this is now an output of type number. Good. And in my template, I need to say, where's the shopping cart? There it is. If somebody clicks on it, then I want to say selected change emit. And I say holiday, give me the ID, and this is what you want to emit. So far, so good. So this is maybe our output, input is a little bit different, but this is something you have already done in the past. And then of course the question now comes up, how do we deal with this here? Well, it's two-way binding. So I could use here the banana box syntax. The longer version would have been that I say selection, not selection change, selected change. And I would then say selected holiday ID equals event. Yep. Of course, also the red thing here comes because of the not supported output. And if I now click here, we see that it's working. Good. Since this is two-way binding, I can also say, you know what? You should also update the holiday ID when this event is fired. So now again, it's also working. Good. But now I can do two things with the signals. The first one, I can say, well, this is two-way binding, so there is now a new type for it, and that's the model. So I say I can allow that this selected is also updated, it's also changed via my parent component, but I also want to be able, when I change it here in my component, that it fires a selected change event to my parent component. And with model, I don't need to define this event anymore. And it will still work, except I have to be careful because in my holiday card now, when I click on that button, I'm not emitting an event anymore. I need to update the signal itself. So I say here selected, not emit, also not call the value, but I say I want to use here the holiday ID. To the outside, to my holidays component, nothing has changed. It's still the old selected and selected change event. It still works. So if I click here again on India and click back on Norway, everything works. But what I can do now in my parent component, because in the child component I'm already done. That's already fine, don't need to do there anything. Just model input and output. But here I can now use a signal for the select holiday ID, especially if I want to run a side effect. So I could say, okay, you know what? This selected holiday is now a signal of 1, and I want, if that one's going to change, that it should rerun. Maybe it should maybe send a request to the backend, or I want to have it computed, which doesn't say selected holiday ID is 1, but that says the name of the holiday. And this is what I'm doing. So I say here selected holiday, or the pretty selected holiday. I say you are now computed, and I need to get access to the current holidays which I have. So holidays, I also want to know the selected one. So this is then selected holiday ID. And then I just say, okay, in my holidays, find me that holiday where the ID is the same as the selected. So holiday. And then I say, well, if it's actually there, it could happen that nothing's there. Then I want to return an empty string. But if everything is all right, then I say selected holiday. Holiday and access the title. So I have a computed of a string return, so signal string. And then I go into my template and I say, okay, where do we have it? Here. I say we have something better. The pretty selected holiday. It is a signal, so we have to call it. We save it. We run it. We'll see, selected holiday, Norway, yes. So I click here on India, we see India, and then it's Norway back again. Okay? And this is everything that you have to know about this new API. You can now work with signals. You can make use of all its It's effect computed functions, reactive functions. You don't need to remember the old lifecycle hooks anymore, and you're very well protected as long as you stick to the rules, accessing the signals, try to access it in the reactive context or in computed. And yeah, so input, model, output, replace the input and the output decorator. Model is both, so where we had in the past to come up with an own input and output decorator in order to provide two-way binding, we have now one command that makes sense. And the two-way binding, as we have already seen before, but also now, the two-way binding also works if you provide a signal to it. So that was quite a long video. We have seen that signals are actually very easy to use, especially if we compare it to RxJS. There are some edge cases, for example, the glitch-free effect, and this implicit or hidden kind of reactivity which might emerge from the effect function. So in that case, as I've shown it, you have one part where you kind of activating the signals that you want to listen to or where you want to be a consumer of, and the rest then goes in the untracked function. We have also seen that RxJS doesn't have to go away. You can still use them, maybe not in the components, more in the services. And it's very easy to jump from signals to observables, but also to jump back. So we have these kind of methods from the interoperability module available. Last thing is also then this new API, and I think you have seen how easy it is when you have only to work with signals and you might not even have to remember the lifecycle hooks anymore. It just is a better developer experience, and we can expect that this continues. And this leads me now to the last point. I mentioned at the beginning that I highly recommend you to switch to signals, although some of the majority of those features are in developer preview. Now I understand that some say, okay, we want to wait. Yeah. Or maybe some say we want to wait until the complete signal kind of transition is finished. We are done and we don't expect any changes anymore in terms of the Angular framework. Because at the moment we see with every major, with every minor version, we see new features which requires you to update your code base quite often. I would not recommend you that you wait until everything is in a way kind of done. Might take a very long time. Because at the moment, if we look at it, we know that in the roadmap we have the signal components which will come out hopefully soon, hopefully this year. If you have that, the next step would be the signals forms, the new forms module, which has also already been announced. The next steps are already in terms of authoring format, so maybe the import property goes away. And we have still this optional RxJS strategy where again, quite huge parts of the Angular API will change. HTTP client, the router, for example, where we have an observable, so there are some changes as well. And if you say you want to wait until everything of that is done and only then you start with the implementation, and maybe you say also if those features leave the developer preview, then I am afraid we are talking here about 3-4 years. And I don't think that you want to wait, that you want to have a code base which you don't touch, which you don't use the latest feature there, because yeah, I mean, it's not something you want to have. You have a very, very old code base at that time. So what I would recommend is just the typical thing that most of developers do, which have to deal with an existing code base, that you just say, okay, when a new feature has to be implemented, or when an old one has to be refactored or extended, then you just come up there and provide the signals or use the signals there or the latest feature that you can. And of course, over time, we hope that our application, our code base will become more and more signalized in that sense. But we will still have a mixture, but that's, I would say, that's the way it is. Good. So if you have liked this video, then please give it a like. I would also be happy if you subscribe to my channel. And if you have any questions, then please just ask below in the comments section of this video. Thanks for watching and goodbye. See you in the next video.